Deus Volt! Welcome to the DevOps Crusade. So who am I and what do I do? I code, I teach, I hack. I'm a full-time developer and DevOps engineer. The things I'm about to talk about in this presentation and share with you are from my experience of trying to actually eat your own dog food and walk the walk, actually implementing security best practices in production-facing systems. I also have experience on how to explain how to do it through blogs, videos, and live classes. So not only am I a developer and instructor, but I'm also a full-time offensive security consultant. So I've seen organizations who did well and architected cloud-native applications that were well fortified and well secured, and I broke into the ones that weren't well secured. And let's go in and let's see what ground we're going to cover. So I'm going to give you an abridged history of the tale of DevOps, and then sprinkle in some technophobia along with victim shaming. That is followed by the technical side of the talk that no one's going to remember, where I explain permissions and access management in S3 and IAM. After that, we'll go over how to assess an AWS security in an AWS account for free, and then concludes with some steps to lock it down if you're just starting into cloud adoption, just starting out fresh. Oh, and if you just so happen to use a different cloud provider, listen up. We'll also be discussing different ways that you can lock it down. It would help. So this is the first DevOps Crusade. So in the beginning, we were using these monolithic structures called data centers, in which all of our computing power was housed in various places throughout the globe. Air conditioning had to be confined oh so neatly. It is a place of LED lights and silicon. And then we realized running a data center sucked. So we moved into the cloud, and this is in 2008. AWS it starts up, and then GCP and Azure follow suit, and then we decided, hey, we're going to write code that's actually designed for production and then immediately. And in fact, we're going to codify the infrastructure process with tools like CloudFormation and things like that. That all starts in this first grand and epic DevOps crusade. And then you get headlines like this. So tell me if you've heard this before. A minor mistake led to a massive leak. It's not the first time we've been here, is it? So we've had S3 data leaks affecting millions of users every 6 to 12 months for years now. When I first gave this talk, Capital One was the big breach of the headline, but one of my coworkers informed me that Twilio left an unsecured S3 bucket, so they get on the list. So this is awful. This is the result of really, really bad management. And it's really tragedy, because I'm telling you, companies can save billions of dollars, and then the rest of us could be saved unnecessarily suffering with 17 lines of JSON. And I'll share it to you, post a screen, share it, how we get that and how we can secure S3 buckets. But you've got a tale of two types of cloud breaches. You've got Capital One, which they weren't stupid. They didn't leave an open S3 bucket out on the internet with credit card data for everyone else to grab hold. And then you have the simple case, Twilio, which is, yeah, simple S3 misconfiguration. But with Capital One, it wasn't that the S3 bucket was wide open. The attacker got an EC2 instance that happened to have permissive S3 access. So it's not just as simple as configuring one thing correctly and making sure you adjust the dials and switches on one resource. If you're thinking about cloud security, you have to you have to think of the entire environment and how all the resources and all the pieces fit together. But that brings us to the second era of DevOps. So still, you've got the first crusade, the first era of DevOps. People are still drinking the Kool-Aid, embracing the cult, and pushing breakneck features at crackhead speeds, and building things up and breaking them down even faster. And guess what? The DevOps cult community has taken over. Everything is moving towards automation in the cloud because remember, running a data center sucks. So we've all embraced it. So that brings us to the second era of the DevOps Crusade, an era spanning roughly 2012 to 2018. And this is the counter revolution. Best practices. We as security professionals finally get a grasp on this whole DevOps thing, and DevSecOps is coined. AWS well-architected framework is completed, so on and so forth, and everything. And this is where all that enthusiasm starts to die. It's not like I don't like the idea of DevSecOps, but it's not sexy. It's bulky, it's ill-elegant. There's no, like, if you are on a date, right, and you're finally go out, not now, but I mean before the plague and all of that, and you're talking with an IT professional and you just whisper DevSecOps, there's no romance there anymore. So, and plus, security isn't something that you throw in the middle of things. It isn't the purpose, the purpose of an organization isn't to be the most secure organization. Security is the price you pay for doing the things that you want to do. So it's not something that you can just throw in the middle of. It's something that has to be integrated into everyday business. But of course, I mean, why not just go full into it? I mean, everyone should be involved into the process of DevOps. I mean, it's a team. We're all working together, you know? So what do I mean when I'm saying DevOps? What I'm saying and what I'm arguing and what I'm advocating for is not Crusade 1. It's not counter Crusades 2. I'm arguing for a third one, and I'm arguing for going back to the roots, going back to basics, going back to the fundamental idea, and that is genuine collaboration between development, security, and operations. Tools don't build tech, teams do. And so what I'm advocating is for the annihilation of silos. I'm advocating that we develop processes that ensure that code that is written is designed to operate and function well. It's about it's also about empowering developers to write secure code that works from the get-go. And that is the North Star that we're orienting ourselves around. That is what we wanted with Agile, with these other DevOps crusades. And that is the center of what we're trying to express today. So I'm going to give you a bunch of tools, techniques, and strategies, but it's up to you to use them effectively in your team. And it's up to you not to bludgeon your developers with other security requirements with this, but actually build holistic, complete, functional, beautiful, and elegant software. So What's so complicated about S3? In order to understand how to get to that North Star, get to that elegant place, you need to figure out what's so complicated about this stuff. Well, there are two options to manage S3. And I say options in the same way that I say seatbelt and airbags are options. The first system is IAM roles and policies, and IAM has to do with users or entities acting on a user's behalf. The second system is a bucket policy, in which the bucket itself will determine who will open itself up to. So let's start with an example for IAM policies. I'm a user in my company's AWS account. As a developer, I have access to source code and various pieces of infrastructure that's relevant to me as a developer. Now, as a consultant, I also have the ability to spin up an EC2 instance for cracking passwords if I'm doing a pen test or I'm on an engagement. So each of those roles is defined through separate IAM policies, and these are just JSON strings that specify what I as a user can and cannot access. But you need to understand that this doesn't apply to just users or groups of users. Amazon resources also are federated and governed by these IAM policies. So let's say that you're using Code Pipeline, and that's just a simple CI/CD tool to deploy code and to manage build processes for web applications. So if you have the Code Pipeline, that is something that has its own role. That is something that has its own policy, and within its policies, it has to be given access to GitHub, and it also has to have access to the S3 bucket. And so you can federate that access. So through IAM roles and in-place IAM policies, you can control and manage that access. But for S3 particular, because it is extremely unique in the AWS system, you also have S3 policies, and this is the bucket with its own lock. And at the level of the bucket, you can specify who can have access to this bucket, and with various levels of granularity. You can lock it down, that make it so that you have to do an MFA verification before you can even access files of it. You can make sure that only encrypted files are uploaded, or you can leave it open, which is actually an appropriate response if you're just using the S3 bucket as a public static website. So what you do depends on your particular use case in your environment. Messing up in either an IAM policies or S3 bucket policies can open yourself up to unnecessary exposure. So as we've seen in many times for the past 3 years, if your bucket policy is wide open, you give everyone access to all the contents and all the files stored within. But if you mess up your IAM roles, you can also give services unnecessary access that they don't need. And that could lead to that delayed sort of breach that we see in Capital One. It wasn't that the bucket was wide open, that the attacker could walk through and get in. It was by pivoting through various misconfigured parts of the infrastructure that the attacker was able to steal credit card data. So secure use of S3 involves mastering both elements, if you will. Insecure use is just 3 easy clicks away. So this is beautiful. This is elegant. This is the demo. This is the demo that sold to your C-level executive on the cloud in general. How easy it is to set up EC2 instance that has access to a specialized server for storing passwords. Just create the IAM role, attach the S3 full access policy, which is which is created by default in every AWS account and involves 4 clicks. And then you can set up and launch your EC2 instance, which is just a click-through wizard. Beautiful, elegant, easy, but you're not supposed to do this. What you're supposed to do instead is go through, create the IAM role, create and edit the custom S3 policy, the custom IAM role fetching S3 access, attach that custom policy, set up and launch the EC2, and if you happen to mess up, access denied. And then which you trace back and then just keep running through this process in which, because you got to shut down the EC2 instance when you're applying new roles to it. That makes it easier. So I'm not going to lie to you. Secure use of the platform is difficult, tedious, requires a lot of trial and error. It's not something you can hand off to the security team after it's already in production. And when you're thinking about cloud native applications, you're not just talking about 2 services interacting with each other. In this case, S3 and EC2 instance. You've got dozens of services that also have different varying levels of access. So this is just the step-by-step process for just 2. Imagine other cloud native apps where there's dozens upon dozens of services and dozens upon dozens of resources within those services. So with all the scope of all of that, how do we assess security on AWS resources? Let's pretend that you're coming in late at the game. Pretend that you are the only AppSec or DevSecOps person or security engineer tasked with securing dozens upon dozens of web applications. Where do you start when you're assessing and when you're looking at the security of these things? Well, that's what these 3 demos are about. And they're just about free tools, freely available to anyone who's running an AWS. And it's not free tier and then you're gonna get $300,000 bill at the end of the month. These are actually free. And they don't necessarily require configuration. They don't require a CI/CD thing. The Parliament in particular is open source, and the first 2 are just freely available to anyone who has an AWS account. So, without further ado, let's get started. So, we hop into the IAM Policy Simulator. In this case, you've got 3 groups: users, groups, and roles. You can run this simulator as any user or group unless that access has been federated or blocked off to see like various levels of granularity to tweak different policies. So let's give you an example of a bad S3 demo role. So we hop in, we see that this is pretty lazily put together. We got Amazon S3 full access policy, and we select all, and we run the simulation. And everything is allowed. Green means go, but it also means go for any attacker that has the ability to assume this role. So imagine if you're applying this to that EC2 instance. It's simple. You're running a web application off of that. If someone can manipulate or mess with that EC2 instance and have access and be able to hop on that box and assume this role, that means they can do whatever they want in your S3 environment, in your S3 buckets throughout your AWS environment. Some of these policies are just admin level of access. So being able to just place it to set up different, some people use S3 for storing encrypted keys, for our for public websites. This particular person that has the ability to assume this role can wreak all sorts of havoc. So, is there a better way? And that is it, and there is. Here's the example of a secure S3 policy. When you're thinking of S3, everyone's typical use cases is, hey, I want to download files. I want to modify or upload files. I want to list a file, all the contents of a file in a particular bucket. Those are the three major use cases. You don't need the ability to put encryption configurations on buckets here. When you're allowing access to S3, you just need those three things. In industry terms, this is the principle of least privilege. In industry terms, it's the principle of least privilege. To everyone else, it's need to know basis, need to access basis. So we run it in the simulation and we see that everything is denied. And that means absolutely everything. And that's kind of weird, since we thought we just specified the get object property. And here's where we hop into the beauty of the simulator. Not only can you run simulations on wildcard, meaning every bucket against every object, but you can also be granular with the permissions and do simulations on resources that don't even particularly exist. So I'm going to copy and paste this ARN and change this particular policy to here. And I know some people may be getting nervous in my use of wildcards here. All this means is that this is specifying that for all files or all objects, as they're referred to S3, and directories in an S3 bucket, we'll run this simulation on all of these. So that's why there's the /*. And once we do that, we see that the simulation resources changed. Now let's go into a bucket policy to one of the bucket actions and apply it this way. And hey, we're going to run this simulation over again on a specific bucket, on files or objects within that bucket. And let's see what happens when we run it. And there we go. We're allowed. So what we've done with this particular policy, with these 17 lines of JSON, is that we've allowed this particular EC2 instance the ability to download, the ability to upload, and the ability to list the file contents of a particular S3 bucket and the files within. You can adjust this policy and experiment and add some granularity here. So for example, if you want to specify a specific directory into files under a specific directory, you can modify the policy here just to add a /foo and a /. So all the files under directory foo, you have access to put, get, and list and view those files. And that's great. But let's say we understand that, hey, this isn't the level of access we need. There's a use case for being able to delete files and be able to remove objects. So the way you do that is just with the delete object action. Apply that, rerun the simulation. Let's scroll up to the delete. We see delete object operation was not allowed. When we rerun the simulation, blood ow, the delete object is allowed. And I hope you understand that this isn't just something that's simple that you can use with S3. You can use this to simulate policies and roles across a variety of AWS services. So let's say that in a real world case, you're creating a CloudFormation service role. So that particular role may need to have access to generate a CloudFormation stack, CloudFormation template, be able to, and then to be able to create various resources like in S3, like a code pipeline, like Elastic Beanstalk instance, for example. All of those types of, you can simulate complex roles and policies using this simulator. But let's say you're not a madman and you don't want to write JSON live before an audience. So how is there an easier way to create valid AWS policies? And that's where it leads us to the AWS Policy Generator. And this is just a tool that allows us to make the JSON generation process. So we can create the exact same, this exact same role that we did before just by navigating and going through the dropdown. So delete object to be able to remove files, get object to be able to download, list bucket to view the contents of a particular bucket and be able to refer to it by name, put object to upload files, and that's about it. And you can specify all you need for that is the ARN. So ARN some bucket, and comma delimited, and there we go. We add the statement, we generate the policy, and we have the same policy that we've written, and we did not have to deal with messing with curly braces and all of that. And if we need to, run a simulation on that, simulator also has the new policy mode in which you can, in an editor style, create and apply and gives you a platform to just mess with it. So before we talked about also S3 bucket policies. And so if you can federate S3 access through IAM, why would you even touch S3 bucket policies? And the reason because some things are really, really easier just by applying a policy at the bucket level. They just really are. And so the generator, it's fine. The generator also gives us the ability to create and craft a bucket policy that we can copy and paste and that we can put into. And I will walk you through an example of a particular use case now. So let's say this bucket is holding confidential data. We don't want anybody to be able to upload any files to this bucket without them being encrypted first. So in order to do that, what we're going to do is we're just going to jump into we're going to create a denial policy. And the beautiful thing about deny policies and IAM or in S3 policies, those rules have precedence over any other allow statement, any other way of allowing access. So we're going to say deny policy, and then we're going to add star for the principal. And what does that mean? So a principal in S3 bucket policy specifies who is the outside party trying to connect into this bucket. So we're saying we're denying everybody who tries to connect to this bucket and perform this particular action in case the action is put object anyone who's trying to write a file to S3 for any file, just copy and paste this, ARN real quick. Any file under this bucket that meets these certain conditions and criteria. And so if they don't have if they have an incorrect encryption header, we don't want it. So the way that you specify that the encryption header needs to be set is you say string not equals, and then the S3X AMZ server-side encryption. And this particular string that we're doing is AES 256. So if that header comes in and its value is not equal to AES 256, we don't want it. We don't want it, and we don't want the file to be able to upload successfully. And so we add that as a condition, and we add that as a condition. And honestly, we can add that as a statement. Now, this alone is not enough to force encryption on every upload. In order to, you also have to be able to deny all encrypted uploads. So we're going to say, hey, if the header doesn't even exist, or if the header's value is null, we don't want the file anyway. And then we just do that with a wild star principle, meaning we don't care who you are, even if you are allowed to connect and access this bucket. We're going to hop into actions, delete, not delete, put object, right there. And we're going to do the same ARN. And we're going to add another condition and saying, hey, if this particular header is in fact null, meaning it's not present there, then we also don't want it. And we generate the policy, and this is very similar, and you can compare this policy later. This policy is very similar to what AWS recommends for doing this exact same use case, for specifying and making sure that, hey, we don't want any unencrypted uploads to be allowed, on this bucket. And so the AWS Policy Generator has that ability. It gives you an easy to go to resource for generating the policies. But when I say that there is the question here is, how do I know what each of these actions are? For S3 alone, it's 96, and one cloud security expert estimated to be over 5,000 actions across AWS. 5,000 access. How do you figure out what each of these does? And there's no shortcut to this beyond going to AWS documentation. That is the primary resource. But some problems are so severe that there are actually open source tooling available to help you protect against them. And so that's why we will be switching to the VM real quick. And we'll be doing a quick demonstration of Parliament. So Parliament is a CI tool which shows you the security of various the security of implications behind various IAM policies. So if we do a quick ls of the dictionary, we see that it only has one file. Let's cat that real quick to show its contents, and we see, okay, This is an IAM policy governing access to S3, and we've got two actions. You've got the get object and the put bucket policy actions for some bucket called bucket. What are the security implications of applying this policy? And that is a question that Parliament is able to answer. So, Parliament, we have a file with get with put. And here we go. The reason why this particular policy is insecure is because of this action right here. If you are allowed arbitrary write access into an S3 bucket policy, that's an easy avenue for privilege escalation. So honestly, you can set the buckets policy to whatever you want. If you have an IAM policy, if you're allowed to set the bucket policy to whatever you want, you have the ability to open it up to the entire world. You have the ability to open it up to various different AWS accounts that aren't affiliated to the organization. And you also have the ability to lock it down, to make it to override and take over that S3 bucket so that only one person could on a different AWS account could take over it or use it. So that action alone allows for a privilege escalation possibility, and that was detected using Parliament, a free and open source tool. And so if there was a three-step process on just locking down AWS, of wrangling together DevOps done wild, I know the AWS well-architected framework is that North Star, where I know that collaboration and team, that is a standard, but how do we get started with just handling the initial dumpster fire? And we could start with the 3 easy steps. Institute a policy, a process for actually reviewing not only changes to the code, but changes to the cloud environment. What do I mean by that? So I don't say DevSecOps. I say secure DevOps. Requires review and analysis when new resources are being provisioned and used. Mention all the code changes and AWS changes in a PR and baking this in the process of the dev. Also, making sure that you can also using CloudFormation templates to have the infrastructure in the code base. So you absolutely know what is being created and what are the infrastructure and the resources from there. How is that influencing the code, and what does that look like in production? That's step number 1. Step number 2 is understanding that you need to have a reasonable amount of isolation and a de-escalation of permissions before something goes live. If something is already live, you need to figure out, okay, what do each of these pieces actually need to communicate with each other? Chances are they don't need full write access. The resources probably don't need full write access to each other. So one of the easiest ways that you can do this is have a separate AWS account for ongoing development projects versus production. We understand that isolation is needed for code. It also needs to be applied to serverless infrastructure with a price tag attached. And making sure that full access permissions just aren't allowed at all. So, and then the third part is a culture change. Security patches are bug fixes. Security improvements are features. Treat them as such. Don't just throw it to the sec team when there's a fire or things are burning down. Try locking it down before you move it to production versus after it's already in production. And then you can use the various tools that I've talked about, that using the policy simulator to debug permissions, and then not only to make sure that these things actually work, but actually go on that next step of securing them. And so using all the techniques we discussed here, we don't have to be left the DevOps that looks like this, or security that acts like this. We can move forward to that genuine collaboration. And we can also, importantly, prevent these headlines. Imagine if attackers, when instead of getting access to an S3 bucket or a particular resource that has admin mode in environment, that they only get access to a particular resource and their permissions are fine-grained, and you've instituted that principle of zero trust throughout each component within the infrastructure. You could save billions of dollars, and you could save a lot of misery. And that's not, but the tech, fixing the tech isn't the only last problem. We need security champions embedded through development teams and security teams that will help developers and aid them to succeed. There's a lot of Band-Aid fixes. There's a lot of security controls. And our keynote speaker mentioned and went through a lot of that. I'm just going to end with an invitation to join me on that third crusade, to leave the planet in better shape than we entered in, and let's use the technology just to facilitate that. Deus Vult, God wills it. Thank you for your time and attention.
Thank you, Ochaun. That was awesome. Thank you. All right, and I'm checking. Have you been watching the chat?
Almost always works. If you need a SQL injection, you can start.
I will definitely.
I haven't seen a lot of questions in there, but looks like we've got 300 folks in there right now. So
Okay.
if you want to you're welcome to hang around in the chat if you want. Anybody has any questions? But if nothing else, thank you for your time. Awesome job. Thank you.
Thank you.